Let's move on with the Weissen's bridge, a little bit twisted type of Weissen's bridge circuit. You are given a circuit like this, right? Okay, right. This is an IIT question, okay? I think you were asked in 2009. That's what the textbook or book has been, not the textbook, guys. I'm taking this question from another book, right? R, right? This is B, A. This is a circuit which is given to the as a question, and you are asked to solve this circuit. How would you solve it? You can solve it if you understand a little bit logic of the circuit and point marking, etc. Same potential points can you find? See, how many of you guys can solve by yourself within 1 minute? They have understood the concept. If not, you guys can take your time. I will start solving it. Pause it, do it by yourself. Okay, let's move on. I will do it. Now, let's mark some points, guys. This, let's take it as x, let's take it as y, right? Right. If this is x, this is y, this point also will be y. This point is b, means this point is b, this point is b, this point is b. This point is a, means this is a. Right, this much is clear? Right. Now, can I draw an equivalent circuit for this, guys? Of course I can draw. I'm going to draw, okay? Let's take, how many points are there? There are 4 points. One is A, one is B, X and Y. Right. Between A and X, I'm going to take one R. Right. Well and good. Right. Now between X and B, there is an R. Right. Between B and Y. Right. Between B and Y, there is an R. Well and good. Now between A and Y, where is A and Y? Right, there is an R. Right. But there are only, how many resistors came up? 4 resistors. How many resistors are there? 1, 2, 3, 4, 5. That means I have left off AB. So there is an AB resistance. There is a resistance between X and Y also, right? So there are 6 resistors. 2, 3, 4, 5, 6. Yeah. Okay, there are 6 resistors, but they are not contacting, right? No resistors are overlapping, means I have to draw an overlap like this. What do you mean by crossover? I hope you understood what I did. If you want to make, I will make another color. See, this resistor is jumping over the other one. It is jumping. Jumping means the resistor between X and Y has no contact with the resistance between A and B. This much is clear. Now how many of you guys have understood it? Out of this, if you understood the Weissen's bridge, it is very easy to solve this condition. See, in this Weissen's bridge, let's remove, or let's not consider the point or the resistor between A and B. Then if I just don't consider this guy, right, it will be a proper Weissen's bridge, R by R1, R by R1. So I can consider point potential at X and potential at Y is same. So no current flow in this wire, or I can say I can remove the resistance between X and Y. So the equivalent resistance will be, if I draw, it will be very simple like this, between A and B, right? Because I'm not neglecting while considering the earlier condition. And there is a resistance like this and resistor like this. This is R, 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 and this is A, and this is B. Now circuit is solved, right? I hope you understood. See, I neglected the resistance between X and Y because this R by R. You have to look into C1 by C2 is equal to, sorry, R1 by R2 is equal to R3 by R4 like this. Then this potential is same, you can neglect it. So I removed it. So the rest of the things has to remain as it is. Now R and R are in series, so equivalent resistance will be 2R, and this is an R and this is 2R, right? This is A and B. Now 2R and 2R are in parallel, so it becomes R, right? 2R and 2R resistance in parallel, same values divided by 2. 2R by 2 becomes R. Then this is R and this is R, right? A and B. R and R are in parallel becomes resistance values R by 2. That's your answer. Clear? Right. Let's move on to 2002 question. Now let's move on to a little bit complicated circuit, guys. But the basic concept is Wheatstone's bridge itself. It was asked in IIT 2002 question. Right, let's draw the circuit. It's 2R, 2R. See guys, I might not be drawing it beautifully because we have time constriction. So this is R, this is also R. Alright, this is, oh shit, I'm cursing like anything. Okay, this is 2R, this is 2R. Sorry guys, don't listen to the other things which I am telling, just listen to the portions I am teaching. Okay, we have a circuit like this, right, and it looks very, when you look into a paper, it looks very beautiful, not like this. Anyways, it looks like a star in between and then there is a rectangle, okay, with the values. Anyways, so this is a question and you are asked what is equivalent resistance and you were given options like this: 8R, R plus R divided by 3R plus R, and option B was 2R plus 4R, option C was 5R by 2 plus R, and option D was 2R R by R plus R. Out of this, which option comes up? Pause it while solving, guys. Pause the video, you guys can do it yourself if you can. Now how would you solve it? I gave you the clue. The essence is it's basically a Wheatstone's bridge itself. It's very simple, guys. Look, the two parts are there, right? It's a repeated pattern. There's another way of solving, but we'll solve first, or I will tell you by Wheatstone's bridge. While taking the other method also, we try to include this concept. Okay. Anyways, see these two parts, right? These two sections are repeated pattern. So at a time, I'll consider this part. Then I will consider remove this part and this part, right? You will consider these two guys or two sections as two parts, separate parts. Yeah. Now let's consider this part only. Now do you see a Wheatstone's bridge here? Of course you see. What is the ratio here? 2R by R. It becomes what? 2R by R. And the same value is coming up here also, 2R by R, right? This much is clear. So the ratio of the legs of the Wheatstone's bridge are or is same. So I will say the Wheatstone's bridge is balanced. So this point, let's name it, oh, this is P and Q. So let's point A and point B are having same potential. So if they are having same potential, I can neglect those guys. Happy? Right. Now, do you see something else? Now I will remove this much section. Oh, the shadow is coming. Take another level paper. Right. Now let's consider this part. Where is the value? Alright. Okay. Let's take here R. Right. Right. So this part, this entire section is R by 2R, R by 2R. Again, it is a balanced Wheatstone's bridge. Again, this point B and C. Okay. B and C are having same potential. I can neglect 2R resistance. Now, how would be the equivalent circuit be, guys? It will be like this. 2R, this is 2R, 2R, this 2R goes off, so there is only this R, who got the square slanted figure. Okay, anyways, so this becomes 2R, 2R. In between these two guys goes off, R, right? Now this is easy to solve, guys, right? This 2R and R, 3R, this and R, 2R, this 2R and 2R are 4R, right? Now solve these three guys who are in parallel, 3R and 4R. Guys can take anything. Let's take these two guys. This is 2R, sorry, I didn't look here, 2R, so this is 4R, sorry, 2R plus 2R, 4R, it's 2R, right? Now 4R and 4R, now it's easy. 4R, let's take those resistance which is easy to solve. 4R and 4R are same values and there are two guys and they are parallel. So R by N, so R by N is here R by 2 and in place of R there is 4R. So 4R by 2 is 2R. So if current circuit will be like this, 2R and there is small 2R in parallel. That is R1 into R2, that is 2R into 2R divided by 2 capital R plus 2R. Guys, when I am telling, listen to the parameters I am telling, because it is very difficult to write this R1 into R2 etc. repeatedly. So when I am telling R1 into R2 means this resistance into this resistance divided by sum of these two resistance. That is the equivalent resistance value for when two resistors are in parallel. 2R into 2R divided by, right. So this will be 4 capital R small r divided by 2. This is common, right. So I can cut these two guys. The answer will be 2R divided by 2 into R plus R. Right, the answer is very easy. So which option it will be? Option D. Clear? Right. It's not tough if you understand the logic of it. Now we'll do a basic another section circuit. Right. Solved it, guys. You are seeing a circuit. Now previous one I hope you guys have solved it. Look into the circuit, try to solve it, guys. See, 4 options are given. You have to find which of the options is correct as per this circuit. I hope you guys can do it by yourself. Okay, let's see. If you are not able to solve it, look into the video, guys. Okay, now I am going to solve it. See, once you look into the circuit again, you will feel it's a beautiful circuit. It looks like what it's a quadrilateral plus 2 triangle shape. But guys, when you look into the circuit in point of physics, you have to see many things. 2 ohm, 4 ohm, 2 ohm, 4 ohm, 2 ohm, 4 ohm, or ratio 1 by 2, 1 by 2, 1 by 2. Again, it's just an extended Weiston's bridge. That's something which you have to understand with the first point of view. So that is this 2 4, this 2 4, 2 4 2 4, 2 4 2 4, 1 by 2 ratio. So I have asked you guys to remember one thing, that means in between these two panels, right, if you consider at a time, consider these 4 guys, right. So this 1 ohm goes off, consider this guy, this 1 ohm goes off. What will be the equivalent circuit, guys, now, right? This will be the equivalent circuit, right, when this 1 ohm and 1 ohm goes off. Now, so the first point, there is no current flowing through and P and Q. There is no current flowing through and P and Q is true. So this is correct, right? Because we neglected it, right? It's a Weiston's bridge. So P and Q as well as S and T, there is no flow of current. Now let's move on. Rather than B, let's see C. That is, potential at Vs is less than Vq. Let's see, potential at once I consider that in the case of PQ, I2 is right. I2 is a current which is flowing from P to S. Right. Now that means if current is flowing from P to S means potential at P is greater than potential at S. Right? Clear? Then I'm writing it sidely. Current is flowing from where? P to S. So Vp is greater than Vs. Right? If Vp but is equal to Vq, they are of same potential. So substituting here, Vq will be greater than Vs. Right, so this term is also correct, right? Vq is greater than Vs. So option C is also correct. So I can tell you this question was removed because they had 2 cases. Anyways, I'm just telling you, but it's a very good question. Now, potential at U is greater than potential at S. So this option is correct. So A and C is correct. Now we'll go for B and D solving. That is, we have to find the current I1, that is total current in the circuit, and I2, that is current which is flowing through this branch. How would you solve it? Now let's move on. Now I1, this much I can know. Total current is total voltage by total resistance, or R equivalent, right? So what is total voltage? That is 12. Now what will be R equivalent be? You guys can solve it, right? This is 6 ohm and this is what? 12 ohm. 6 ohm and 12 ohm are in parallel. So 6 into 12 divided by 18, that is 3. The equivalent resistance is 4 ohm. I hope you did understood how it is done. R1 into R2 divided by R1 plus R2. These 3 guys form 6 ohm. These 3 guys form 12 ohm. Right? So you get 4 ohm as equivalent resistance. So you substitute here. It will be how much? That is 3 ampere. Right? So I1 is 3 ampere. I1 is 3 ampere. The option B is also correct. Now let's move on to find I2. That is very easy, guys. I2 is the current which is flowing through this entire branch. I1, that is how much is I1? 3 ampere. 3 amperes currents, how much part will be going over here and how much part will be going over here? It's a common sense question, How much comes? See, this is having 6 ohm, right? Total 6 ohm, and this is having 12 ohm. So how much resistance is less here, right? This is less, so more current will be flowing here. In which ratio? In 2:1 ratio. The resistance is in 1/2 ratio, right? When resistance increases, the current is reciprocal of it. So if the resistance is 1/2 in ratio, then current will be in 2:1 ratio. That is, double amount of current will be flowing through this branch. So if I consider the current, that is I2 by I3, I2 by I3, it will be 2:1, right? So that means I2, that is I2 is 2/3, that is total is 3. Out of this 2 is only reaching, so how much is total? I1, that is, I can say I2 current is 2/3 part of I1. That is, total currents only 2/3 part reaches here, rest 1/3 parts reaches here. So 2/3 by I1 is how much? 3 ampere. So this is 2 ampere. So I2 is 2 ampere. Right, so this is also correct. So I can say I2, if it is 2 ampere, so how much current is flowing through this here? 1 ampere. So here, if it is 2 ampere going, here will be 1 ampere, and this is totally 3 ampere. Clear? This is a common sense section, guys. Clear?